Hi guys, Big Monday here, and today I'm doing a quick Starmade tutorial. I want to show you guys a binary counter clock and how you can use this to do multi-step signaling processes and set up some really elaborate blinking light sequences or activation sequences. So first off, we'll quickly go through everything we've got here. We've just got a basic pulsar here. When it's activated, it'll pulse. When it's deactivated, it'll stop pulsing. Simple enough. I've got two timer blocks here, so it's a 1 second between each activate and deactivate. Oh, cat, get out of the way. Okay, so and here's the next bit is our binary counter. Now you see these flip-flops, they are going to store our information. So each one of them is going to store a bit of information for us. Now if you know how computers work, that'll make a lot of sense to you. If not, if you don't understand binary, counting up these numbers is going to be a little bit awkward for you. So if you don't understand binary, like Google it, go and look how binary works. And this is going to make this a lot easier to understand for you, and then come back and watch this video. So basically each column we add here doubles the amount of numbers in our system. So doubles the number of options. So we've got 2, 4, 8, 16. So we've got 16 different places. This is going to show numbers 0 to 15. That's important that 0 is our first place, so it's not 1 to 16, it's 0 to 15 for 16 places. Okay, and to build this, it's relatively simple. The lights are only here to make it glow and look pretty. So what we do is we have our first NOT gate, which then feeds into an AND at the back of every column, and it feeds into the NOT gate directly in front of it. Then all the AND gates will feed into the NOT gate directly in front of those, and each of these NOT gates will feed into the flip-flop in front of it. So that's straightforward enough. Now, each flip-flop will then feed into every AND gate at the back of the column to the right of it. So the first one will feed into all three, because all three of those columns are to the right. The second one will feed into the next two. The third one will only feed into the last one. Now you can extend this as far as you like using the same principle. You can put another column in. Just make sure that the first NOT gate powers every AND block at the back, and every flip-flop is attached to every AND that is right of it, and then it should work out fine. So what this is going to do, every second it's going to, our pulser is going to send a pulse here, and then the clock is going to count up 1 every second. So and what it's going to do is the lights will sit on, and the lights will effectively be our bytes, so our bits, and show us what number in binary we're showing. Now, all the stuff I've got here, these are just pulsars, and what they're to do is, instead of having a solid light, we're going to have a blinking light when it's on. It's just to show different ways you can set this up to make different lighting arrangements. So when we've got the first bit lit up, so that's a 1, this one will flash. When we've got the second bit lit up to be a 2, this one will flash. When we've got the first and the second lit up, which will be a 3, both these will flash. So we can set up either solid lights that go on and off in sequence, or we can set lights that begin blinking and end blinking in sequence. So just let me start this off, and I'll just sort of count through the clock, so those of you that aren't really fantastically familiar with binary can sort of watch the numbers. So I'll start that going. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's all 16 positions, including the off position. Now I'm going to stop this on a random number. I'm going to stop it on, leave it a little way through, one that's got more than one block. That one. Okay, so this is to a 5. So as you can see, we've got this block representing a 4, this block represents a 1, they add up to a 5. So we've got, so this number is 5, and these ones are blinking nice and happily away. So it shows the same number but just in blinking lights. Now, so there's 16 steps in this process, and we want to pick different numbers to spread out different blinking light systems. So how do we do that? Okay, so to be able to make a number, each column is going to need a NOT gate in front of it, and your flip-flop will need attaching to the NOT gate. And then what we do, we work out what numbers we want. So I'm going to say, so I want a 5 in this case, and for a 5, this one is active and this one is active. So what we do is we link both of these to an AND gate. So we'll link, so basically both that are on blue we will link to an AND gate. This one is 5, by the way, I've got them numbered. So I've actually already made 1, 3, 5, 7 and 13, so prime numbers. So yeah, so we've got 2 AND gates here. We're going to connect the ones that are lit up for 5 to this one, and then for the ones that aren't lit up, you see we've got the lit up NOT gates. For the ones that are off, we're going to connect those to the AND gate at the back, and then we're going to connect the back AND gate to the front AND gate. And what that's going to do is this will only come on when those 2 are off and those 2 are on. So it will only come on when it displays 5. And I can quickly show you building another one. Let's take 14. Okay, now if you're not massively familiar with binary, it might be easier for you to sort of work out in advance which ones it's going to need and then light those up. So I've already got a 13 here, so what I'm going to do is I'm going to let that count to 13. 7, 8, 9, 10, 11, 12, 13, 14. Right, so we've got 14. And let's just make sure we've got no blocks selected. And for 14 we're going to put an AND gate and an AND gate. We're going to put a light, and we're going to put a display block that shows us our number. We don't have to put a display block, this is just so we can keep track of exactly what's being made here. So we're going to connect the AND gate into the light, the back AND gate into the front AND gate, and now because we've set it on the right number, we're going to connect all the flip-flops that are lit up to the front AND gate. And all the knots that are lit up to the back AND gate. Right, so we've got 14 there and 13 there. So what should happen is that one should light up after this one. So if I start this going again, and just back up so we can see it all. Remember, we've got 1, 3, 5, 7, 13 and 14. Oh, and it's I've not turned the light off in the first place. If you've not turned the lights on or off correct when you first made them, once it's gone through one cycle, they'll all turn on correctly anyway. So we're going to get 13, and then it should go off, and the next one will go on. So 13, 14. So brilliant. So we can now use this if we really want to. We can connect this to really elaborate different lighting displays. So we can have them either solid when they're active, like I've got these ones, or we could, if we put a longer delay in between, we could maybe have them blinking, and we can do some really elaborate lighting patterns with this. The thing that makes this so powerful is that I can just put one more column on here and it will double the number of steps I can include. So at the minute we've got 16 steps. If I put 4 more blocks in, that'll give me 32. If I put 4 more blocks in, that'll give me 64. 4 more blocks in, that'll give me 128. And then 4 more blocks in, so double the width, it'll be 256. So if I double the width of this, it's going to be 256 different steps, which if you wanted a different light for each step could take you quite a while to set up all the numbers, but at least it works. It's simple enough. Now these, I've got them staggered just so that we can make it easier to show what I'm doing here, but you can condense all this down. You don't need the lights, obviously. These are just because this is just my sort of lab area where I leave things on demonstration. So you don't need the lighting, you don't need all the pulsers here if you're just going to set up sequence numbers. And once you've done all this, you can set up some really cool things, like we can have lighting going on and off in sequence. If you notice, there's more than one lighting set in each cluster, so they come on and go off in stages. We can also activate this, which is now going to change the pattern. You notice all 4 sets now do the same pattern, apart from the fact there's a little bit of lag. Or we can do, to be honest, you don't need one this elaborate to do this lights, but you see how we've got creeping lights here. We could use it to make a door that retracts quickly at the start of its cycle and then slowly when it's almost retracted all the way. So there's quite a lot of things you can do with this. If you've got, you might have really complicated systems set up to activate movement in a ship, and you could build a transformer with having things operate in sequence, but they may require delays in between to allow time for things to complete. So go away, have a play with this, guys, have fun with it and see what you can make. Go enjoy Starmade, guys. See you later.